Welcome back to the deep dive. Today we're jumping right in, putting on our hard hats, you might say,
Yeah,
because we need to face a pretty stark truth about the construction industry. It's, well, it's kind of an economic anomaly, isn't it?
it really is. You look globally and you see these persistent problems,
Mm-hmm.
material waste sometimes hitting 40%,
40%, that's huge.
and chronic delays,
Yeah.
affecting maybe 70% or even more of major projects. It's clear the old ways, they just aren't cutting it anymore.
Yeah, it feels like an industry that's just begging for a radical shakeup for more efficiency.
Exactly. It's so fragmented, still relies heavily on, traditional, sometimes analog processes. And that just creates massive risk, cost overruns, delays, safety issues that could often be avoided.
So our deep dive today, we're focusing squarely on the digital toolkit that's really designed to fix this mess.
Right.
We're zeroing in on three really powerful concepts. They're interconnected, and they're driving this essential shift. We're talking 4D planning, lean construction 4.0, and digital twins.
And these three, specifically, they directly tackle that critical mission you mentioned,
Hmm.
cutting down physical waste, minimizing disruptions on site from errors,
Uh-huh.
getting that granular real-time progress tracking, and honestly managing logistics at a scale that was, well, pretty much impossible before.
Okay, but before we unpack those three big ones, let's just quickly set the scene. This whole transformation, we often call it digital construction. What does that umbrella term actually cover?
Good question. Digital construction, yeah, it's the broad term. It's about leveraging all these advanced technologies across the entire life cycle of an asset.
So not just one piece of software.
No, it's much more. It's a whole methodology. It includes things like BIM building information modeling, digital collaboration tools, reality capture, using laser scanners, drones,
Right.
and crucially, advanced analytics platforms. It's really the whole ecosystem where our three main topics fit together and work.
Okay, ecosystem, I like that. Let's start with maybe the foundation, 4D planning. So we get 3D is space, and the fourth D, well, that's time. But just smashing a BIM model and a schedule together. It's got to be more than just a fancy animation, right? What's the critical insight it actually gives you?
Yeah, it's much more. The real insight is it's about constructability and preventing risk way, way upstream. 4D planning is essentially your digital rehearsal space.
Digital rehearsal. Okay.
Yeah, you link the 3D model components, could be anything, a specific steel beam, maybe, or the pouring of a particular concrete slab. You link those directly to tasks in your project schedule.
The linking is key.
The linking is key. When you do that, you generate this visual simulation of the entire construction sequence over time. You see it unfold digitally before you touch dirt.
Okay, so right away, that hits waste and disruption. You're spotting clashes, obvious stuff like a pipe hitting a beam. But I want to push past that. Where does 4D really shine in preventing those, super expensive surprises out on the actual site?
Great point. It really excels in identifying trade interference and sorting out logistics staging, much trickier stuff.
Okay, explain that. Trade interference.
Well, think about a complex hospital build, maybe. You got structural teams, mechanical, electrical, plumbing, facade guys, often all needing to work in the exact same area at the exact same time.
Right. Recipe for disaster.
Totally. 4D lets project managers see those resource conflicts like two different subcontractors needing the same hoist, or even two cranes potentially swinging into each other's paths weeks, maybe months before it actually happens.
Months before. Okay, so you avoid a multi-million-dollar delay right there.
Potentially, yes. You're identifying these bottlenecks and inefficient sequences way ahead of time. It's not just about static clashes, but the flow of work.
So optimizing the movement of things and people,
No.
not just where the final pieces go.
Precisely. You can simulate really complex operations, erecting massive equipment, coordinating just-in-time material deliveries. By watching the site evolve day by day in the 4D model, you optimize the site layout, the access routes, where crews stage their materials. It dramatically cuts down the chaos.
Reduces that sort of friction and those unforeseen issues that just eat up the budget.
Exactly. It burns budget and schedule.
Okay, if 4D planning is such a clear win for de-risking projects,
Yeah.
why isn't everyone doing it perfectly already? What are the big hurdles, the stumbling blocks you see?
Well, the stumbling blocks often come down to data quality, and integration. To do 4D well, you need solid inputs.
Right, garbage in, garbage out.
Pretty much. You need a good, reliable 3D BIM model, You need robust scheduling data, usually from something like Primavera P6 or a Microsoft project, and then the 4D simulation software itself.
Okay.
But the really hard part, it's not usually the software itself. It's that critical step of linking the right 3D geometry to the right schedule task, accurately, reliably, repeatably.
That sounds time-consuming.
It can be, especially up front. That linking process and then iterating, analyzing the simulation, tweaking the plan, resimulating, it takes resources. And that's a major hurdle for companies maybe just focused on those initial setup costs, not the downstream savings.
Right. Short-term pain for long-term gain. And that's always a tough sell sometimes. Okay, makes sense. So we planned the sequence with 4D. Now let's talk optimizing the actual process, the workflow within that sequence. That brings us to Lean Construction 4.0.
Right.
So maybe just briefly, traditional Lean focuses on eliminating muda, or waste, right? Value streams, pull systems. How does Industry 4.0 tech, like, turbocharge that?
Yeah, Lean 4.0 takes that core philosophy, minimizing anything that doesn't add value, and just supercharges it with real-time objective data.
Okay, data's the key again.
Always. Where traditional Lean often relied on, manual observations, maybe some historical data, Lean 4.0 uses digital tools, think sensors, think AI. It creates these immediate feedback loops for continuous improvement right there on the project.
Give us the aha tools here. What specific tech is making the biggest dent in waste elimination for Lean 4.0?
I'd say it's absolutely the combination of the Internet of Things, IoT and AI, artificial intelligence and machine learning. Think about IoT sensors. You put them on your heavy equipment, your excavators, your cranes. They don't just tell you where the machine is, like basic GPS.
Right, goes beyond location.
Way beyond. They track its operational health vibration levels, engine temperature, fuel consumption patterns, idle time. Loads of data.
Okay, so instead of just waiting for a breakdown or doing scheduled maintenance.
Exactly. You move to predictive maintenance. What's the impact?
Yeah, what's the quantifiable benefit there?
Well, the real insight is you shift from just tracking past downtime to potentially wiping out maybe 70, even 80% of unscheduled maintenance events. Major breakdowns.
Wow, 70 to 80%.
Yeah. The AI algorithms consume all that IoT sensor data. They spot anomalies, patterns that suggest a failure is coming, and they alert the team before it happens.
So it radically cuts equipment downtime.
Right. Keeps the workflow smooth, continuous, boosts productivity significantly, which is, a core principle of Lean.
That sounds incredibly powerful. But it makes me wonder, if AI is crunching all this data, optimizing deliveries, maybe even suggesting where resources should be, is the system basically telling people what to do and when?
Ah, that's a great question. The human element.
Does it take away that site manager's intuition, and could that cause some cultural pushback?
That is the perfect critical question, yeah. Right now, these Lean 4.0 technologies, they're mostly designed for, let's say, prescriptive guidance, recommendations, not full autonomous management, at least not yet.
Okay, guidance, not orders.
But they demand radical transparency, and that is definitely a source of cultural friction.
How so?
Well, imagine a site manager or maybe a subcontractor who's used to running things based on their experience, their gut feeling. Now they're getting alerts or seeing dashboards showing their resource allocation, their progress, tracked in real time via sensors.
Feels like being watched.
It can. It shifts authority sometimes from that I know best intuition to the data suggests this is optimal. And Lean 4.0 requires everyone to agree to share that real-time progress data, which honestly many traditional contracts just weren't built for. It requires trust.
Excellent point. Culture and contracts needed to catch up with the tech.
Right.
So we've used 4D to visualize the plan, Lean 4.0 to optimize the flow. Let's shift to the end product itself, the asset, digital twins.
Right. The living model.
We've talked about 3D models, BIM. What really makes a digital twin different from that static model we might have started with in design?
The key difference is dynamism, life. A standard 3D model or even a detailed BIM model is mostly a static blueprint. It shows the design intent, right?
The way it should be built.
Exactly. A digital twin, though, is a virtual replica of the actual physical asset or system, or even a process that is living and dynamic.
Living? How so?
It's continuously connected to its physical counterpart through real-time data feeds, data flowing in from IoT sensors on the asset, maybe maintenance logs, energy meters, weather data, operational inputs, all feeding the virtual model. It has a pulse.
Wow. So it's not just a pretty picture, it's actively tracking performance.
Yeah.
And you said it can simulate future scenarios.
Exactly right. The core parts are You've got the physical thing itself, the really rich virtual model, that constant stream of real-time data connecting them, and then sophisticated simulation capabilities built on top.
Okay. And this provides value across the whole life cycle, you said, starting even during construction.
Absolutely. During construction, it's invaluable for capturing the true as-built conditions as things are actually installed, not just planned.
Closing the loop between design and reality.
Precisely. It helps with quality assurance, making sure what's built matches the specs, and provides an incredibly rich data handover package for the owner or operator when construction finishes.
Okay, handover. And then once that bridge or building or maybe a processing plant is actually up and running, where does the big financial value show up for the owner?
Well, the long-term value in operations and maintenance, or O&M, is potentially massive and often very quantifiable.
Like what?
Think about ongoing energy optimization. Using real-time sensor data, the twin can help adjust HVAC systems, lighting, other operational parameters, potentially cutting operational energy use by, say, 15, maybe up to 30% in some cases.
Okay, that's significant operating cost reduction.
Definitely. And maintenance. It moves beyond just predictive, this pump might fail soon, to being truly prescriptive.
Prescriptive.
Yeah. So if a pump shows signs of wear, the twin doesn't just send an alert, it can simulate the impact of that potential failure on the whole system, and then it can recommend the most efficient time and method for replacement based on current operational needs, maybe even material availability or technician schedules, minimizing disruption.
That's a huge leap. Okay, so that ability to optimize not just construction costs, but efficiency over, say, a 50-year lifespan. That's the real key to achieving true life cycle management.
That's the goal, a continuous thread of data.
So how do these three big ideas, 4D, Lean 4.0, digital twins, how are they actually tied together technologically? What makes them work as a system?
Yeah, they're definitely not standalone things. They're intrinsically linked really by the need for a common unified data environment. You need the data to flow.
Okay.
You can think of it like this. 4D planning kind of sets the initial sequence and baseline using design and scheduled data. Lean 4.0 injects that real-time operational feedback during construction, how things are actually progressing, where the bottlenecks are, and then the digital twin acts as the persistent dynamic hub. It holds all that information from design through construction reality into operations across the asset's entire lifespan.
That demands serious interoperability, though, doesn't it? Getting different software, different data types to talk to each other. Historically, that's been a massive headache for construction.
The Achilles heel, absolutely. It's a huge challenge. Which brings us to the technology backbone, the platforms that actually enable this integration. Companies like Bentley Systems, for example, are really focused on solving this full lifecycle integration problem.
Right. So how do they tackle it? What do their solutions look like?
Well, they approach it by providing dedicated platforms for each stage, but ensuring they're integrated. So for the 4D planning stage, they have a platform called S1CHRO 4D.
Okay.
It's specifically designed for that visual planning, digital rehearsals, project controls, and crucially, it's built to federate or bring together data from all sorts of different scheduling tools and 3D modeling software. It plays nice with others.
Handles that input challenge we talked about. And then for the digital twin itself.
For the twin, the foundation is their iTwin platform. This is designed as an open, scalable cloud platform. Its whole purpose is to let people create, visualize, and analyze digital twins, specifically for infrastructure assets.
And the open part is key there, right? It solves that interoperability headache by letting data from different places, different software vendors, different types of engineering models combine seamlessly with reality data, like from sensors.
That's the core idea, yes. It acts like a central nervous system for the assets data.
Okay.
And this allows them to unify their other tools like ProjectWise for project delivery, SCN-CHRO for construction, AssetWise for operations into one continuous, interoperable data stream. They sometimes call this the infrastructure cloud. It connects the dots.
The infrastructure cloud. Okay, that sounds incredibly compelling. Integrated. Powerful. But transformation is never that easy, is it?
Rarely smooth, no.
Let's make sure listeners get a clear picture of the hurdles. We mentioned the significant upfront investment costs. Beyond the money, what are the toughest challenges organizations really face when they try to adopt this kind of high-tech integrated workflow?
Well, we touched on interoperability, getting the tech to talk. But honestly, the biggest hurdle, I think, by far, is often the cultural resistance.
Back to the people problem.
It always comes back to people, doesn't it? This is where shiny new tech slams into decades of established tradition of how things have always been done.
All right.
Imagine, like we discussed, a site superintendent, 30 years experience, very successful. Now they're being told an AI algorithm, or maybe a central planning team using a 4D model, has a better sequence based purely on data they might not fully trust yet.
Yeah, I can see the friction there. My gut tells me otherwise.
Exactly. That creates resistance, especially when you pair it with needing to share real-time progress data from IoT devices, data that subcontractors especially might see as proprietary or maybe even risky to share. What if it makes us look bad?
And tied right into that culture issue is the workforce itself, isn't it?
Right.
We're asking people who maybe grew up on 2D blueprints and paper forms to suddenly manage dynamic 4D models, interpret AI maintenance alerts.
Absolutely. The upskilling challenge is enormous. You need BIM managers who now need to understand data science principles. You need site crews comfortable using maybe AR or VR headsets for quality checks or following digital work instructions.
It's a huge shift in required skills.
Massive. Organizations really need to tackle this strategically. Phased adoption is usually key. Don't try to boil the ocean and revolutionize everything overnight. Train people, show the value, build trust.
Good advice. Phased approach. Okay, looking ahead then, we've talked about Industry 4.0, Lean 4.0. What's the next evolution? Where's this all headed? 5.0.
Yeah, what's next? I think the next big wave involves moving beyond just predictive capabilities into more generative ones.
Generative,
Yeah.
as in creating things.
Exactly. We'll likely see AI shift from just analyzing existing designs or data to actively creating optimized design options itself.
Wow.
Based on constraints you give it material costs, maybe carbon footprint targets, constructability simulations from 4D, even long-term performance goals fed back from the digital twin. The AI helps generate better starting points.
Okay, that's fascinating. What else?
We'll definitely see more advanced robotics becoming common on sites, especially for tasks that are dangerous, highly repetitive, or need extreme precision. And immersive tech, augmented reality, virtual reality, they won't be novelties anymore. They'll be standard tools for on-site quality checks, remote expert assistance, training.
So moving from simulating a design, analyzing performance,
Healthy.
towards actively, maybe even autonomously, generating and building the design. That really does sound like the final frontier of efficiency.
What is our
It feels like the
our
next
mission?
essential phase, doesn't it?
What is our
Especially if the
purpose?
industry is going to make the huge sustainability and productivity gains it so desperately needs.
Well, this has been a really critical deep dive. We've laid out how 4D planning lets you visualize time, see the sequence, how Lean 4.0 optimizes the actual work processes using real-time data, and how digital
What is
twins
our-
provide that living,
mission?
breathing record across the whole
What is our
asset
purpose?
lifecycle.
And crucially, how they work together.
Right. Their integration, their synergy. That really feels like the blueprint for a construction future that's significantly more sustainable, more efficient, less wasteful.
But, as we discussed, realizing that potential isn't just about buying software. Organizations really have to cultivate that culture of innovation, embrace transparency, and implement these changes thoughtfully, strategically. Phase strategies are key.
Which brings us to a final thought for you, the listener, to maybe chew on. Considering those challenges we talked about, especially the cultural resistance, the need for workforce upskilling, which of these three big concepts do you think presents the single greatest cultural hurdle for construction organizations to overcome today? Is it 4D planning? Is it Lean 4.0? Or is it the digital twin?
Good question. Which one really hits the biggest nerve in terms of changing how people work and think?
Something to mull over. Thanks for tuning in to The Deep Dive.
What is our mission? What is our purpose?